Lesson 19 is factoring quadratic expressions by grouping. I threw an extra S in there accidentally. But quadratic expressions by grouping, 19.1 is introducing factoring by pulling out the greatest common factor. So 19.1a, or problem A, says factor the GCF out of each expression. So before we get into these problems, I kind of just want to review what the greatest common factor is. So if I have like two numbers, let's say I have a 24 and an 18, and I want to find the greatest common factor between both of those numbers. Well, I can list the factors of each. Factors are like numbers that multiply to get our like final number. So for 24, the factors are 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then for 18, the factors are 1 times 18, 2 times 9, 3 times 6. So the greatest common factor is something they both have. They have it in common. And then the greatest means the highest number. So out of 24 and 18, the greatest common one is 6. That's the largest number that they both have in common. So that's something that we're going to focus on for this section, is finding that. And then we'll also learn how to find the greatest common factor when it comes to variables. Okay, so A says 45x plus 72. So first we need to find the greatest common factor, or instead of like writing out greatest common factor or saying it each time, something that we use to like kind of shorten it is GCF. So if you hear me say GCF, that means greatest common factor. So between 45 and 72, I'm just going to make a list because, you don't have to figure it out in your head. If you can, you're more than welcome to, but I just don't want you to forget that you can kind of do a little scratch work to find it. So 45, that's one of our numbers. So one of the factors is always the number in itself. So 1 times 40, or sorry, 1 and the number, not the number in itself, but 1 and 45. 45 is not an even number, so 2 would not be a factor. But I could check to see if it's divisible by 3, and you can do this with a calculator. So you do 45 divided by 3, which is 15. So that means 3 and 15 are factors of 45. And then since it's not even, I won't be able to divide it by 4 or any other even number. So I can skip that. I can check to see if 45 is divisible by 5, and you may already know that like 5 times 9 is 45, so you could list those. But if you don't know it, that's okay. Like you can just use a calculator and kind of guess and check until you come up with all the factors. And then it's not going to be divisible by 6 because it's an odd number, and if like I can't divide it by 2, I'm not going to be able to divide it by any other even number. I can check to see if it's divisible by 7 if I'm not sure. So you'd use a calculator and do 45 divided by 7, and you get a decimal. So that means it's not divisible by 7. It's not going to be divisible by 8. And then I could try to divide it by 9. If I divide 45 by 9, that would give me 5. But that's the same thing I have right here. So I would just start to loop back around so I can stop after 5 and 9. And then for 72, so always 1 in the number, so 1 times 72. 72 is even, so I can divide it by 2, that's 36, so 2 times 36. I can check to see if it's divisible by 3. So 72 divided by 3 is 24. Oops, 3 times 24, 72. I can check to see about 4, and we're just going to keep going, and I'm just like, you can use calculator if you do it in your head, that's totally fine also. 72 divided by 4 is 18, so 4 times 18. It's not going to be divisible by 5 because if it was divisible by 5, the number would have to end in a 0 or a 5, but we can try 6. 72 divided by 6 is 12, so 6 times 12. We can try 7, and again, some of these you may know, like I can't divide 72 by 7, so you don't have to use a calculator to check it. We can try by 8, is 9, and then the next number we would try would be like 9, and if I divide 72 by 9, I would get 8, so I would start looping back around into the same combinations I already have. So those are all the factors of 72. you want, you can list them in like order, so from 1 all the way up to 72, but I don't think it's completely necessary. You just have to look at which one is the greatest common one between the two. So I'm going to just start with like the highest factors for 45 and see if they're also factors of 72. So what that means is like, so the biggest factor of 45 is 45, but that's not a factor of 72, so they don't have it in common. The next biggest one is 15, but that's not a factor of 72, so they don't have it in common. And then the next one is 9, and then 72 has a 9. So those must be the greatest ones that they have in common. So that's our greatest common factor is 9. So between my coefficient and my constant, like kind of the number part of the expression, my GCF is 9. And when I factor by the GCF, I'm doing like the opposite of distributing. So distributing, if you remember, is like if I have something, say 3 times x plus 4, distributing would be the multiplying where I multiply into the parentheses. So like 3 times x is 3x and 3 times 4 is 12, so it become plus 12. I'm doing that, but in reverse order. So I'm going to go ahead and just set up my parentheses, and we can actually kind of use like the distributing process to help us to kind of work backwards. So I can think, okay, if I was going to work backwards and kind of undo my problem, I would do 9 times whatever I'm about to put here. And 9 times whatever I'm about to put there should bring me back to 45x. Well, I'd have to multiply 9 times 5 to change it to a 45. And then I would have to multiply an x to get this x. And then I can do that same thing with the second part. So 9 times whatever I'm about to put here would have to bring me back to that 72. I would have to multiply 9 by a positive 8 to get this positive 72 up here. So that's one way of doing it. I'll show you the other way really quick. Don't like erase what you have on your paper yet, because I'm gonna erase mine and just show you the alternative way, and you can decide which way works best for you. But you should get the same answer at the end either way. Okay, so we've already figured out the GCF is 9. And then the GCF is something that we also like divide out of each term. So I can do 45x divided by 9. 45 divided by 9 is 5. And then for the x, I'm not dividing the x by any more x's, so that stays the same. And then 72 divided by 9 would leave me with 8. So I have that same answer as I did before, 9, and then parentheses 5x plus 8. That's my final answer. Okay, and then for b, 4x squared minus 32x. So you may know, if you don't know, it's okay. You may know that 4 is a factor of 32. So since this number is a factor of that number, that's going to be my greatest common factor. If you weren't sure, you could list it out. So I'm just going to list it really quick. So for 4, the factors are 1 times 4 and 2 times 2. And then for 32, the factors are 1 times 32, 2 times 16, and then 4 times 8. So the greatest one they have in common is 4. That's always why we always need to list the 1 and the 4 in this case, or 1 in that number, because sometimes it is the GCF. Okay, so I can factor out a 4, but there's also another common factor that each of these terms have. So remember, like this is one term and this is another term, and they both have an x. One, of course, has like x squared, one has x to the first power. So if they both have an x, then you can factor one out. You can pull out the lower of the powers that they have. So like this one is a second power and this one is a first power because there's no exponent there. So I can pull out the smaller of those two, so I can pull out an x to the first power. Okay, and then we'll set up our parentheses and kind of work backwards from distributing to figure out what we would have left. So if I were to distribute and work backwards in this problem, I would be multiplying 4x by something right here, and that would bring me back to 4x squared. So 4x times x would bring me back to 4x squared. And then 4x times something right here would have to bring me back to negative 32x. I would have to multiply 4x by negative 8 to bring me back to negative 32x. Okay, I'm going to run through the other kind of like mindset of this problem really quick, just like in terms of distributing. So if my GCF is 4x, I would be dividing that out of each term. So if I do 4x squared divided by 4x, that leaves me with 1x, or just x. Sorry. And then the next term, negative 32x, divide out the 4x, leaves me with negative 8. So when we're working backwards, we think, what would I need to multiply to go backwards? But like when we're working forwards, we're dividing, because like multiplying and dividing are just like opposites of each other. It's like walking forward versus walking backwards. They do opposite things. Okay, so final answer, 4x, and then times x minus 8. And you can also always check your answer by distributing. So if I wanted to check this really quick, I could do 4x times x is 4x squared. 4x times negative 8 is negative 32x, and it should bring me back to my original problem. So that's a good, quick, easy way to check your work as well. Okay, moving down to C. So 12x to the fifth plus 20x squared. I'm going to make a quick list of the factors, and again, you can make the list if you want to. If you are confident finding the GCF in your head between 12 and 20, that's also totally fine too. So 12, my factors are 1 times 12, 2 times 6, 3 times 4. And then for 20, my factors are 1 times 20, 2 times 10, 3, no, not 3, wow, okay, 4 times 5. Got like a little bit too in a routine there. Okay, so the greatest common one between both 12 and 20 is 4. They both have the 4, but that's the biggest one that they both have. So from my coefficients, the numbers, I can factor out a 4. And then they both also have an x. One has an x to the fifth, one has an x squared. I can pull out the lower of those two. So I can factor out an x squared. Okay, and then I'll set up my parentheses. And then if I'm working backwards, like trying to figure out what to distribute, it would be 4x squared times something right here. They would have to bring me back to 12x to the fifth. So I would have to multiply the 4 by 3 to get to 12. And then I would have to multiply the x squared by 3 more x's, so x cubed, to get back to x to the fifth. Because remember, when you multiply powers, you add the exponents, and 2 plus 3 would bring me back to 5. Okay, and then the next part, 4x squared times what would have to go right here to bring me back to 20x squared? Well, I'd have to multiply the 4 by a positive 5 to get it to change into 20. But for the x, like this is an x squared, and so is this, so I don't need to multiply any more x's because they already have the correct power. So it's just going to be a 5 in that place. Okay, the alternative way of thinking of it is like with dividing. So if I were to do 12x to the fifth divided by 4x squared, 12 divided by 4 is 3, and then x to the fifth divided by x squared is x to the third power. And then 20x squared divided by 4x squared. So 20 divided by 4 is 5, and then x squared divided by x squared cancels all the x's out, so that's why there's no x left inside the parentheses. One thing to be careful about is when you are factoring out the GCF, if you notice that something that you have left inside the parentheses, there's like two numbers that both have a GCF still, or like there's both terms that both have an x, that probably means that you did not factor out the correct GCF initially. So I just want to show you like kind of what that looks like, a counterexample or something that would be like incorrect. So let's say I did not find the correct GCF between 12 and 20, and I said the greatest common factor was 2. And you don't need to write this. It's just kind of like a example of a mistake that we could make. So I factor out a 2x squared instead of a 4x squared. And when I divide that out of the 12x, it leaves me with 6x cubed. And then when I factor that out of the 20x, it leaves me with 10. So I factored the 2x squared out correctly. I didn't make a mistake there. My mistake was I did not pick the correct greatest common factor because between 12 and 20 it was 4, but I only picked a 2, but you can find your mistake. So if we check what we have left inside the parentheses, there is still a greatest common factor other than 1 between 6 and 10. Like 6 and 10 are both still divisible by 2. So that means that I did not factor out the true greatest common factor. I just pulled out one that was in common, but not the greatest one. So you would probably want to go back and make a list at that point and make sure that you got the like true greatest common factor, the biggest one possible. Okay, and then D, this one has a whole lot going on. So 12a cubed b squared minus 18a squared b cubed plus 30ab to the fourth. So we'll take it piece by piece. We'll start with the coefficients and then the a's and then the b's. So the coefficients, those are the numbers in front, 12, negative 18, and 30. So if you want to make a list, you can. I am thinking like a number that pops out of my head that I can divide into each of those is 6 though. So I'm going to go ahead and try 6, and then remember I can kind of use what we just talked about in the last example to like see at the end if I pick the right number. So I'm going to factor out a 6 for my coefficients because that's the greatest common factor, or I think it's the greatest common factor between 12, 18, and 30. But again, if you are not sure, just make a list. It doesn't take that much extra time. You can just make one for all three. Okay, and then for my a's, this is an a to the third power. This is an a squared. This is an a to the first power because there's no exponent. I can only pull out the lowest one, so I can only factor out an a to the first power. And then for my b's, I have a b squared, a b to the third power, a b to the fourth power. I can only factor out the lowest one, so I can factor out a b squared. Okay, and then that's my GCF, so I still have to fill in the rest with parentheses. One kind of like another way to like, I guess, find mistakes is if your problem started with like this problem started with 1, 2, 3 terms. That means when you finish your problem, you should still have 1, 2, 3 terms inside the parentheses. Even if like something, one of the original terms was your exact GCF, if you divide something by itself, you're left with 1, not 0. So you should always have the same amount of terms left inside the parentheses after factoring out the GCF. Okay, so same thing, we're just gonna go piece by piece on each like term. So we'll do 12 divided by 6 right here is 2. And then a cubed, that's the third power, divided by a to the first power. So when I divide powers, I subtract the exponents. And sorry, I'm using the division way this time instead of the kind of multiplication way, but I'll do the multiplication way after, or at least talk about it. So a cubed divided by a to the first power, that would go down to a squared, because I would do 3 minus 1. And then b squared divided by b squared, that cancels the b squareds out completely, so there's no more b's on that term, and that's okay. So then we'll move on to the next term. So it would be, hold on, let me erase these so I can kind of start fresh. So it'd be negative 18 divided by 6, which is negative 3. And then a squared divided by a to the first power, so we would do 2 minus 1, which would be a to the first power, but if it's a first power exponent, I don't need to write it. And then b cubed divided by b squared, so 3 minus 2 is 1, so another first power exponent that I don't need to write. And then we'll move on to the last term, so it'd be 30 divided by 6 is a positive 5, so plus 5. And then a to the first power divided by a to the first power. If you have the same powers, they just cancel each other out, so there's no more a's there. And then b to the fourth power divided by b to the second power, so you do 4 minus 2 is 2, so I'm left with a b squared at the end. So then, now this is going to be your final answer. Couple things to check for, especially if we didn't make a list for the GCF, is to make sure that all of my coefficients have no GCF other than 1. So that means like the only common number that I can divide this 2, this 3, and this 5 by are 1, so that's good. And then they all can't have like a variable in, so all 3 terms left in the parentheses can't have the same variable, which like here we have an A, here we have an A, but not at the end. So they don't all 3 have A's. We have a B here and a B here, but not over here. So they all 3 don't have B's. So that's good. That's just kind of the way that you check that you got the true GCF initially. And then I'm just going to run through really quick and like kind of talk about the multiplication strategy if you prefer to use that way. So if I think in terms of multiplying, I would do 6 times what would get me back to 12, 6 times 2. A times a squared would bring me back to a cubed. And then I'm trying to get from b squared to b squared, so that's the same. I don't need to multiply any more b's, which is why I didn't have a b here. Okay, and then the second term, 6 times what would get me to negative 18? I would have to multiply it by negative 3. A times what would get me to a squared? I'd have to multiply in another a to the first power. And then b squared times what would get me back to b cubed? I would have to multiply in another b to the first power. And then the last part, the last term, 6 times what would bring me back to 30? It'd be 6 times 5. A times what would bring me back to a to the first power? I'm not changing my power of a, so I don't need to multiply in another a. And then b squared times what would bring me back to b to the fourth? I would have to multiply in another b squared because I would add the exponents to get to b to the fourth. Okay, if you just watch that example and you're like, what the heck is going on? It was a hard example, so don't stress about it, but also remember, like, you can rewatch it as many times as you need to, and just give yourself time to get some practice in before you sweat it. Okay, so 6ab squared and then times 2a squared minus 3ab plus 5b squared. Okay, moving down to 19.2, this section is called factor by grouping. So we have 2 examples here. You can see they all have the steps on the right side. I would highly recommend pausing the video and writing those down, at least for the first example, because having those to kind of refer back to are super, super helpful. So example 1, factor the following expression: 5x to the fourth plus 15x cubed plus 10x squared plus 30x. So step 1 says factor out the greatest common factor, or GCF, of all 4 terms. So this is one term right here, one right here, one right here, one right here. So first we check for what the greatest common factor of the coefficients might be. So the coefficients are 5, 15, 10, and 30. And I know all those numbers are divisible by 5, so I can definitely factor out a 5. And then for my x's, I have an x to the fourth, x cubed, x squared, x to the first power. So they all have an x, so I can definitely factor out an x, but I can only pull out the lowest one they have in common, which is this x to the first power. Oh, I don't know why I wrote 3 in front. Sorry. But anyways, they all have, so I'm going to go back to that because I don't know what I said at this point now. So 5, 15, 10, and 30, they're all divisible by 5, so I can factor out a 5. Not a 3. I don't know where it came from. Anyways, and then for the x's, I can factor out an x to the first power because they all have at least an x, but that's the lowest one, so I can only factor out the lowest one. Okay, I'm going to think of this one in terms of dividing now, because we have a good amount of examples of both. So 5x to the fourth divided by 5x, I would divide the numbers in front, so that'd be a 1. 5 divided by 5 is 1. And then x to the fourth divided by, this is next to the first power, would be x to the third power, because I could subtract the exponents. And then I don't need to write this 1 in front, so I'm going to take that off. And then next is 15, I think I'm going to leave this kind of color-coded. Next is 15x cubed divided by 5x to the first power, so I do 15 divided by 5 is 3, x to the third power divided by x to the first power would be x squared, so I do 3 minus 1, which is 2. Okay, and then the next one, 10x squared divided by 5x to the first power. 10 divided by 5 is 2. X squared divided by x to the first power goes down to x to the first power because it's like 2 minus 1. And then the last part, 30x divided by 5x. 30 divided by 5 would be positive 6. And then the x divided by x, those just cancel the x's out completely, so I don't have any left. Okay, so we have 5x and then times x to the third power plus 3x squared plus 2x plus 6. Okay, so step 2 says cut the remaining polynomial in half. So I'm just going to rewrite this down here without like kind of the color coding, but 5x and then parentheses x to the third power plus 3x squared plus 2x plus 6, and then cut the remaining polynomial in half means take what's inside the parentheses and we're just going to put a dotted line down the middle. So we'll group 2 terms together over here, 2 terms together over here. Okay, and then the step 3 says factor the GCF out of each half. So what that looks like is this 5x needs to continue to stay in front. So I'm just going to copy that down. And then I'm going to switch over to brackets because you'll see we'll be using quite a few parentheses in a second. So it'll keep our work a little bit neater. So a bracket right here. And then back to step 3, factor the GCF out of each half. So if this is 1/2, x to the third power plus 3x squared, I would look at their coefficients, which this is a 1 and this is a 3. So the GCF between 1 and 3, the only number I can divide them both by is 1. And then this is an x to the third power and this is an x squared, so I can factor the x squared out because I can pull out the lower of the 2, and then I don't need to write that 1. And then now, if I factor the GCF out, I have to leave what's left over inside the parentheses. So it would be x cubed divided by x squared becomes x to the first power. And then 3x squared divided by 1x squared, it's like 3 divided by 1 is 3, and then x squared divided by x squared cancels out. Okay, so that's the first part of step 3. So what we just did is we factored the GCF out of this half right here. And then we repeat that process, but with the second half, 2x plus 6. So between 2 and 6, they're both divisible by 2, so I factor out a 2. And then the 6 does not have an x, so I can't factor out an x. So next, to get what I have left over inside the parentheses, I will do 2x times 2. 2 divided by 2 is 1, but I have the x left over. And then 6 divided by 2 is a positive 3. And then now I've factored the GCF out of the second half. That's what happened here. Okay, and then it's really important. So step 4 is super critical. So step 4 says check that the 2 leftover binomials match. So what that means, I'm going to go ahead and say 2 leftover binomials. That is referring to what's inside the parentheses here. So those 2 parts, the x plus 3's, they need to be exactly the same. They need to be the same number, same variable, same sign, like positive or negative, depending on what it is, which these are, so that's good. Step 4 is okay. Okay, and then the next step, step 5, says factor the common binomial factor out of each term. So what we just did is we created two terms, two big terms right here, and they both have an x plus 3. Okay, so I'm going to bring down this 5x, and then I get to pull this x plus 3 out of both. So that x plus 3, I'm going to kind of like undistribute it out of each of those two blue underlined terms. And then what I have left, I guess I didn't need this extra space. Anyways, what I have left over, sorry, got a little sidetracked. What I have left over after I pull the x plus 3 and the x plus 3 out is x squared plus 2. So that's what step 6 is to group the remaining pieces into their own binomial factor so that x squared plus 2, those go in their own parentheses. So I'm going to run through that last step one more time. So it's super critical that these are exactly the same. Once they are, they get pulled out and they get grouped together into one parentheses. And then what we have left over, what was in front of each one, x squared plus 2, become their own parentheses over here. This 5x came from that very first 5x that we factored at the very beginning. So I'm going to relabel these lines a little bit just because they got kind of grouped up. This is actually our final answer though. So we're all the way through step 6. So step 4, we were just checking that these two were exactly the same. And then step 5 and step 6 kind of went together here. So I would say this was step 5 and this was step 6. Okay, so step 5, factor the common binomial factor out of each term. That's what we did with the x plus 3. And then step 6, group the remaining pieces into their own factor. That's what we did right here with the x squared plus 2. Okay, so our final answer is 5x times x plus 3 times x squared plus 2. Okay, so last example, if you need to take a little brain break, maybe pause the video, but just know these take a ton of practice, so it's okay. We'll get through it together. Okay, so example 2, same type of problem, same set of steps. I will probably still need to like relabel them, just kind of like we did in example 1, but starting with the same spot. So it's 8x squared y plus 20xy squared minus 20x minus 50. Step 1. Factor the greatest common factor of DCF out of all 4 terms. So if we look at the coefficients, 8, 20, 20 again, and 50. So if you want, you can make a list of the GCF greatest common factors. I'm going to make one really quick just to kind of remind us that, we can do that. So 8 is 1 and 8, 2 times 4, and that's it. 20 is 1 times 20, 2 times 10, 4 times 5. 50 is 1 times 50, 2 times 25, and then 5 times 10. So, let's see. It looks like the greatest common one we have is just 2. It feels like it should be a little bit bigger, but like 8 and 20, those both have 4, but 50 isn't divisible by 4, so we can't do that. So the greatest one they have in common is 2. So I can factor out a 2 that comes out in front. And then in terms of like the variables, they all have to have something in common. So the first 2 terms, or the first 3 terms, all have an x, but the last term doesn't have an x. So I can't pull out an x because it's not common for all 4. And then the first 2 and the last term have a y, but the middle term does, or the third term does not have a y, so I can't factor that out. Okay, so no variables come out. I just have to divide the 2 out of everything. So 8x squared divided by 2. Since I'm not dividing out any variables, the variables will stay the same. I just have to divide the numbers. So 8 divided by 2 is 4, and then this part stays exactly the same. So x squared y And then 20xy squared divided by 2 would be 20 divided by 2 is 10. And then the xy squared stays the same. And then negative 20x divided by 2, negative 20 divided by 2 is 10, and then not dividing by any variable, so the x stays the same. And then negative 50y divided by 2, negative 50y, or sorry, negative 50 divided by 2 is negative 25, and then the y stays put because I'm not dividing out any variables. Okay, and then step 2 says cut the remaining polynomial in half. So I'm going to rewrite it down below just so it stays somewhat lined up with the steps. If you want to do it right there in step 1, that's totally fine. So 2, I'm just going to copy it. Sorry that you guys can't do that. Okay, so step 2, cut the remaining polynomial in half. So we cut in half what's inside the parentheses. And then step 3, factor the GCF out of each half. So I'm going to bring down this 2, and then I'm going to set up my brackets. I'm going to focus on one half at a time. So the first half is 4xy squared plus 10xy. So between 4 and 10, the GCF is 2. They're both divisible by 2. And then there's an x squared here and an x to the first power there, so I can pull out an x to the first power, and then a y and a y squared. So I can factor out a y to the first power as well. And then have something left over inside the parentheses. So I'm gonna use the multiplication kind of strategy here, and again, it's just really personal preference. So I'm trying to get from this term back to this term. So I could just go piece by piece. 2 times what equals 4? 2. X times what gets back to x squared? X to the first power. Y times what gets me back to y. I don't have to multiply any more y's in because that power is not changing. So because I'm going from like y to y, not changing any powers, so I don't need to multiply in another y. And then for the next term, 2xy times what is going to bring me back to 10xy squared. So 2 times what equals 10, that would be a positive 5. And then x times what to get back to x squared? Oh, sorry, x to the first power. I'm going from x to the first power to x to the first power, so that's not changing, so I don't need to multiply in a new y or a new x. And then y times what would bring me back to y squared? I would have to multiply in another y because I'm going from y to the first power to y squared. Okay, and then now I'll focus on the second half of the parentheses, so over here. So for my coefficients, I have a negative 10 and a negative 25. So most of the time, if the first term is negative, especially you're going to want to factor out a negative. So, and especially, okay, don't write this part because I'm going to make a mistake on purpose so that we can talk about that mistake. So let's say between 10 and 25, I say the GCF is 5. And I factor out a positive 5. And this one has an x, but the other one doesn't. This one has a y, but the other one doesn't. So I can't factor out any variables. I just factor out the 5. So when I factor that out, I'm dividing it out of each term. So I would do negative 10x divided by 5 is negative, and again, you're just still not writing this because I'm making a mistake on purpose, and then I'll go back and fix it. So negative 10x divided by 5 is negative 2x. And then negative 25y divided by 5 is negative 5y. But step 4 says to check that the two leftover binomials match. So the two leftover binomials, that's 2x plus y, and this is a negative 2x minus y. So they almost match, like they both have 2's and 5's, but the signs are wrong, and that's also saying the signs have to be exactly the same. So if the numbers are correct, but the signs are not correct, that means that instead of factoring out a positive 5, I should have factored out a negative 5. So then now if I just repeat that step but with the negative 5, we'll do negative 10x divided by negative 5 a negative divided by negative is a positive 2x. And then negative 25y divided by negative 5, that'd be a positive 5y. And then now if I do step 4 again, okay, I have a 2x plus 5y inside the parentheses and a 2x plus 5y inside the second parentheses. So now my step 4 is okay because they're both exactly the same with the same signs. Okay, and then moving on to step 5, factor the common binomial factor out of each one. So what I just did is I created two ridiculous looking terms. This first one that's underlined, and then now the second one is underlined as well. I'm going to continue to bring down this 2 right here. And then when it says factor out the common binomial factor, I get to pull this 2x plus 5y out of both. And it's going to come out in front right here. So 2x plus 5y. And this is step number 5. And then for step number 6, it says group the remaining pieces into their own binomial factor. So if you, like when I say remaining pieces, like, you know, we already brought down this 2. We factored out the part that's highlighted in pink, the 2x plus 5y. So the remaining pieces are this 2xy and this negative 5 right here. So those go in their own parentheses. So 2xy minus 5. And this is step number 6. And then this is our final answer. So 2 times 2x, oh my gosh, that's crazy. Sorry, 2 times 2x plus 5y times 2xy minus 5. And I wish I could say like, that's it, but that was a lot. So just give yourself a little bit of grace. Know that they take time to practice, and we'll do more practice together.